4.1 Factoring integers. When we are factoring integers, we want to find all of the factors or numbers that go into that number evenly. So if we look at our first set of examples, it tells us to find all positive factors. So when we find all positive factors, it's every number that will go into that number evenly. So if we look at example A, we have 56. So if we look at the factors that go into 56, so all of the numbers that go into 56, we can start with 1 and 56. It's an even number, so 2 goes into it. 2 goes into 5 twice with 1 left over, so 2 goes into 16 8 times. We also see that 4 goes into this number. 4 goes into 5 once with 1 left over, and 4 goes into 16 4 times. And then it's also 7 times 8. So those are all of our positive factors that go into 56. 1, 2, 4, 7, 8, 14, 28, and 56. So if we look at B, we have 49. We're going to start with 1 and 49. It's not an even number, so 2 does not go into it. 4 plus 9 is 13. That's not a multiple of 3, so 3 does not go into it. If it's not divisible by 2 and 3, 6 does not go into it. We know that 7 goes into it 7 times. So the positive factors are the 1, the 7, and the 49. There's nothing else that goes into 49. For 68, we can start with 1 and 68. It's an even number, so it's 2 and 34. Another number that goes into it evenly is 4, and 4 times 17 is 68. And those are all of our positive factors. If we look at D, we have 144, so that's 1 and 144. We also have 2 and 72. 3 goes into it evenly as well, 48 times. If we look at it, the 4 goes into it as well, so 4 goes into 14 3 times, with 2 left over, 4 goes into 24 6 times. 5 does not go into it evenly. It's divisible by 2 and 3, so 6 goes into it evenly. And 6 times 24 is 144. 7 does not go into it evenly. 8 goes into it evenly. 8 goes into 14 one time. And then 8 goes into 64 8 times. So 8 times 18. 9 goes into it evenly 16 times. And then 12 times 12 is 144. So we have 1, 2, 3, 4, 6, 8, 9, 12, 16, 18, 24, 36, 48, 72, and 144. If we find the prime factorization of a number, it's the numbers that make up that number that are all prime when multiplied by each other. So if we look at example A, we have 504. We can see that it's an even number, so we can look at those even numbers that go into it evenly. We can start with 2. It's going to be a large number that we're working with, but we can also see that 8 could go into this, because 8 times 6 is 48. Then you'd have 2 left over, so then you'd have 24. So 8 times 3 is 24, so that would be 8 and 63 that we can work with. The 8 is also broken down to be 2 and 4. The 4 is 2 and 2. So now we're done with those because the 2's are primes. The 63, we can do 3 and 21. The 3 is prime, so we can circle that one. The 21 is not. That's 3 and 7. So now those are prime numbers. So if it helps you, write down all of your prime numbers. We have 2 times 2 times 2 times 3 times 3 times 7. Now we can put this in exponential form. You have 3 2's, so that's going to be 2 to the third power times 2 3's, so that's 3 to the second power, and then that 7 is just going to stay at 7. So we have 2 cubed times 3 squared times 7 is that 504. For B, we have 225. So we know 5 goes into this evenly because it ends in a 5 or a 0. 5 goes into 22 4 times with 2 left over, and 5 goes into 25 5 times. So now we have 5 times 45. 5 is a prime number. 45 is not. 45 is 5 and 9. The 5 is prime, the 9 is not. The 9 is 3 and 3. So now we have 3 times 3 times 5 times 5. The 3 and 3 and the 5 and 5 group up to be 3 squared times 5 squared. For 228, we know that 4 goes into it evenly. 4 goes into 22 5 times with 2 left over, and 4 goes into 28 7 times. That 4 is 2 times 2. Those are prime. The 57 is 3 and 19. So the 3 is prime, the 19 is prime. So this is 2 times 2 times 3 times 19. The two 2's group up to give us 2 squared times 3 times 19. If we look at our next set of examples, finding the greatest common factor between two numbers. You can also do this with 2 or more numbers. When we find the greatest common factor, we need to find all of the factors that both numbers have, and then see the ones that they share. Whichever one is the greatest number that they both share is our greatest common factor. So if we look at example 3a, we're given the numbers of 882 and 945. So start with the 882. We know that 1 and 882, it's going to start us. Then we have 2 and 441. We have 3 and 294. There goes 4. Does not go into it evenly. 5 does not go into it evenly. 6 goes into it evenly because it's divisible by 2 and 3. So 6 times 147 is 882. 7 goes into it evenly 126 times. 9 goes into it evenly 98 times. 14 goes into it evenly 63 times. And then 21 times 42 is 882. So now we start with the 945. So that's going to be 1 and 945, 3 and 315, 5 and 189. We also have 7 times 135. Then we have 9 times 105. We have 15 times 63, 21 times 45, and then 27 times 35. Now, if we look at these numbers, the ones that are the same, we have a 1 on both. We have a 3 on both. 6 is not. 7 on both. 9 on both. They don't both have a 14. They have a 21. No, not the 42. The 63, they have one on both. The 98, no. The 126, no. 147, no. 294, no. 441, no. 882, no. So the greatest common factor there, or greatest common factor there is the 63 on both of these. So 63 is our greatest common factor. If we had more than these two numbers, we would find the factors of that number, that third number, or that fourth number as well, and then find the ones that are the greatest out of all of them that they all share. For B, we have 49 and 127. So 49, we did before, is 1 and 49, and 7 and 7. For 127, we have 1 and 127. Nothing else goes into it, so the only thing they will share is the 1. Another way to do this is you see that this 7 goes into 49. So see if 7 goes into 127 evenly. When you divide 7 into, when you put 7 into 127, it goes in 18 times, but you still have numbers left over. You can also divide that 127 by 49 and see if it goes into evenly, and it doesn't. So we know that our only common factor there is the 1. For C, we have 54 and 136. So the factors of 54 are going to be 1 and 54, 2 and 27, 3 and 18 and 6 and 9. For 136, we have 1 and 136, 2 and 68, 4 and 34, as well as 8 and 17. So if we want to find the ones that are the same, we have a 1, we have a 2. We have nothing else in common. So the greatest common factor between those is the 2. If we look at some more greatest common factor examples, for 19, we have 15 and 25. The 15 is 1 and 15. We also have 3 and 5. The 25 is 1 and 25, as well as 5 and 5. So that 5 is our greatest common factor between those two. For 20, we have 12 and 18. So the 12 is 1 and 12, 2 and 6, 3 and 4. The 18 is 1 and 18, 2 and 9, 3 and 6. So the greatest common factor there is the 6. For 21, we have 22 and 35. So we're going to find the factors of 22, which is 1 and 22, 2 and 11. For 35, it's 1 and 35, 5 and 7. So when we look at these, the only factors that they share is the 1. So it's just 1. For 22, we have 23 and 46. So the 23 is 1 and 23. And that's it, because it's prime. And then for 46, we have 1 and 46, 2 and 23. So the greatest common factor there is the 23.